So throughout geometry, we are basically going to use reasoning to make conclusions and to prove things. In order to do that, one of the first things that's useful to sort of like learn or go over is different types of reasoning. So today we will identify and use inductive reasoning to make conclusions. Now, before we can use inductive reasoning, we should probably understand it a little better. So inductive reasoning is basically making conclusions based on making observations. So basically, we're going to make conclusions based off observations and recognizing patterns. So if it makes it easier, I don't know why this is here, based on observations and recognizing patterns. I'm going to give you some examples. But before I do give you some examples or we read through these, recognize that reasoning through something doesn't necessarily make it true. We are just talking about the ways that people reason, okay? So in the first one, all students in one class have blue polo shirts, right? Therefore, all Daggett Middle School students wear blue polo shirts. To like an average, well, I don't know, if that was, I don't know, if you were just an alien, you came to this planet and you saw this, you might make that observation. But I mean, it's not true. But it's right now, these examples aren't necessarily about if they're true. It's just think about the thinking, like look at the thinking. So you're making this observation about all students, and then you're forming this conclusion about the rest of the students. So let's say you go to the dog park, and then all the brown dogs are small. You conclude that all small dogs are brown. Is this the correct conclusion? No, but it is based off of these observations that you made. So all basketball players in your school are tall. So all basketball players must be tall. Once again, I mean, height's relative anyways, but it doesn't necessarily need to be true, but it's just that line of thinking. Let's look at this last one. So Madi is an excellent swimmer. That's something you observed. You also observed that her family has a swimming pool. So Madi's sister Martha must also be a great swimmer. So basically, you're just like, they both have a swim. Madi's good at swimming because of the swimming pool, and her sister's there, so she must also be a good swimmer. Like observations leading to conclusions. Trying to look for patterns. So let's use it to finish or to continue some of these patterns. If you look here, 0, 2, 4, 6, we keep adding 2. So we can conclude, or we can reason, that the next term would be 8, the next term would be 10, and so on and so forth. Because we're just adding 2 and adding 2. Let's look at example 2. In this one, we add 1, we add 2, then we add 3. So if we're continuing this pattern, we made some observations, messed around with it a little bit, but we would conclude that this would be plus 4 and you would get 10, and then plus 5 and you would get 15, and then it keeps going. This next one, 1, 4, 9, 16. So we add 3. We add 5. So next you're like, I don't know. And then this one you're adding 7. So 3, 5, 7, these all seem like odd numbers. So the next one is 9. So that's 25. And then we're going to add 10, get 35. And so on and so forth. Next we have these stars. So I'm going to make 2 more of these. not going to be perfect, of course, but you know, it is what it is. So the shading's on the left, and then the shading's up here. The shading's on the right. So I imagine the shading's going to be over here, and then it's going to keep going and be over here. And I guess it'll keep going in a circle. I'm not sure if that middle one, there's no way like figuring out if that middle one's ever going to be colored in. So now we have these boxes with circles and the square. So I'm going to create a box and another box. We know it's going to continue. And we know that there's going to be a circle. Okay, first thing is we notice that this box is on the inside and then on the outside of the circle. Inside of the circle, outside of the circle, inside of the circle. So I'm going to write myself a note. And this one's going to be outside the circle. Now, it's kind of rotated, so it looks like a diamond to me. And then it's a square. And then a diamond, square. And so this will be a diamond. And this one will be a square. Or if you don't like diamond because it's the beginning of geometry, it's just turned, right? It's rotated. And lastly, we need to know where it's going. So this is bottom, right, up, left. This should be down here. So inside like this. So down, right, up, left, down, right. It should be on the right, outside square. So I guess we continue. We end up with the same pattern. It goes like this. Basically, this little thing moves around, we'll say. So in this example number 6, we have 3 circles. So we know for sure that's gonna, well, let me try it out a little bit. Try, it's not gonna be perfect. And let me try another one. And we continue. So this is broken up into 2, and then 4, and then 6. I imagine this one's gonna be 8 pieces. 1, 2, 3, 4, 5, 7, 8. And the next one should be 10. This one's going to be a little harder for me, so bear with me. See, already. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Not perfect, whatever. Close enough, right? So we're looking at this, and we shade in the top left, or the top half, and then left, and then this is the left, this one is the left on the top half. And there you go. Thank you.